Hey guys, we're on 11.6, our second to last lesson for Unit 11. It's the number e and the natural logarithm. So our objective today is that students will be able to use and find the inverse of this special letter e. So as you know in math, there's some numbers that are way more important than others. So some important numbers in math are 0, 1, remember the I, and pi. So today we're going to learn another important number, which is the letter E. So like pi, which is 3.142, and it goes on and on and on, that is an irrational number, and so is E. E is approximately 2.72, and we're using this mostly in an exponential modeling. So the first question says, which of the following graph shows y equal to e of x? So using your calculator, I want you to go to graph. How do you get the letter e? So you go to this little pi thing and you choose e to the x power. And if you hit enter, you're going to see it's an increasing graph. It's an exponential increasing graph, which makes my answer choice number 2. And the reason why is because the e is a number that's greater than 1. Remember when we did exponential function? If the number is greater than 1, that means it's going to be an increasing graph. Now let's see how this is put into place. Here we go. Exercise 2. A population of llamas on a tropical island can be modeled by this equation, where t represents the number of years that it was introduced. Assume that t is equal to 0. Find how many llamas they are. So my formula, remember, this is my t. So I know the population is 500 e to the 0.035, and I know t is 0. Plug that into your calculator just the way it is. You should get the population is actually equal to 500. So when t, which is the number of year, started with 500. Now it says, algebraically determine the number of population to reach 600, rounded to the nearest tenth of a year. So I know I want my answer to be 600. And I know this is my formula that it's modeled by, 035t. So basically what I need to do is to solve for t. So since I want to solve for t, what am I going to try to do? I'm going to try to get e by itself. So here I'm going to divide both sides by 500 because my goal is to get e by itself. This is going to be 035t. And then I'm going to work this out. What's the inverse of e? Is finding the log. So this is the log of 600 divided by 5 is actually 1.2. So I'm going to write that in. And then this becomes the log of 0.035t. Now, because this is the inverse, remember, what do we do with the log rule? This is going to be the log of 1.2. And remember, this power rule, I take this in the front, my exponent, so 0.035t, and then this becomes the log of e. And from, just to make a note, from here to here, this is the power rule. Power rule. So now that I have this, I want t by itself. What do I do? So I need to get rid of everything here is multiplying. So what I'm going to do is, if I take the log of 1.2, divide everything by 0.035, the log of e, I will get t, because my ultimate goal is to get t by itself. And because you have such amazing calculator, you put this in the calculator, you will get approximately, and it says rounded, so I'm going to approximate this, it says approximated to the nearest tenth, meaning one decimal place, you'll get 5.2 is approximately t, meaning 5 years, 5.2 years. And that's how long it will take for the population to get to 600. Now, let's moving on. We have something, because they're so important, y equal to e of x, the inverse of that is known as the natural log. Um, the inverse of y equals to e of x is the same thing as saying y is equal to ln of x. So these are inverses. So natural log, like logarithms, gives an exponent as its output. In fact, it gives the power that we need to be raised. So, without using your calculator, just try to figure these out. So, ln of e is the same thing as me saying the log of base e to the first. And then how do you put this in the calculator? So really quick. Actually, no, we want to do this without the calculator. But base, all I'm going to do is saying is that whatever my exponent is, that's exactly what I'm going to get. So this will be 1. For example, ln of 1 is going to be the log of base e to the 0 power. Because what is 1? E to the 0 power is 1. So then this becomes 0. Same goes for this. The ln of e to the 5th is the same thing as saying the log to the base e of e to the 5th. My answer will be 5. So again, in fact, just remember the power must be raised to the e in order to get the output. This is the same thing as saying the log of base e to the 1/2. So my final answer here will be 1/2. The natural log follows actually 3 basic log laws. Remember we talked about those earlier? So the following problems give you additional practices with these laws. And these are something that we talked about earlier. So it says which of the following is equivalent to this? So remember, this is division. So whenever I see a division sign, I know that it's going to be, what is it? Subtraction. So this is ln of x to the third, take away of ln of e squared. Now remember, now we're going to use the power rule. 3 comes in front. Ln of x minus, what does this give you? This actually gives you 2, because we just said this is the same thing as saying the log of base e to the second, and whatever my exponent is, that's why it is. So this is actually choice number 2. Now the last question that I want to look at, it says solve the following expression, express your answer in exact terms of e. So now let's try to solve this out here really quick. We have 2 ln of x plus 3, I'm going to get rid of that 5, is equal to 8. I want to get rid of the 2, so ln of x plus 3 is equal to 4. We're good. Now how do we rewrite this? This is where we have to go ahead and rewrite this. The log to the base e of x plus 3 is equal to 4. Remember this? Then we use our, remember the special thing, the cheat I showed you? The log of base 10 to 100 is equal to 2. So basically it's 10 squared is equal to 100. So using that, we're going to get e to the 4th is equal to x plus 3. And then how do we solve for x? So we have e to the 4th minus 3 is equal to x. So this had to do with a few laws. So here we had to do the isolation log. Then from here to here, we use the natural, which is, remember this here, the inverse here. That's what we need to work on. And then our final answer was e to the fourth minus 3 is equal to x. It says leave it in terms of e. Alrighty guys, there you go. Simple number e and the inverse, which is the natural logarithm. Go ahead, try those practice problems. See you.